Hello everyone, and welcome to our breakout session. Scale your machine learning practice and streamline collaboration with Azure Machine Learning. My name is Daniel Moth, and I lead a team of amazing PMs working on Azure Machine Learning. AI is changing the world, and at the heart of that are machine learning models. With ML becoming mainstream, more and more organizations are looking to adopt a unified enterprise-grade MLOps platform that will help them deliver responsible ML solutions to market faster. That is where Azure Machine Learning comes in. Today, I'm excited to share with you the latest capabilities in Azure Machine Learning, which is helping customers capitalize on the transformative potential of machine learning across many industries and across many business functions. Before we dive deep into Azure Machine Learning, let's look at how our AI technologies are developed at Microsoft. It starts with our breakthrough research. At Microsoft, we have 8 research centers worldwide with thousands of researchers focused on areas like computer vision, human language, and autonomous systems. We've developed an impressive portfolio of 22,000 patents and over 3,500 research papers specific to AI. Microsoft was also the first to achieve human parity in vision, speech, and language. Building on all that is our set of AI services, which are not only available to all of you, our customers, but also used by the other Microsoft product teams to transform their businesses. We make available externally exactly what we use internally. Let's have a look at that AI service portfolio. Our AI is embedded and tested by many Microsoft applications. For example, if you use Office 365, when you insert a picture on a slide, you have likely seen the PowerPoint Designer capabilities that provide you with redesigned slide ideas. Or in Outlook, you may have used suggested quick replies. These amazing capabilities are trained on Azure Machine Learning and served by Azure Machine Learning. So millions of Office users every day improve and validate the quality and scale of Azure Machine Learning that then all of you can benefit from. Data scientists and AI developers should look at our Azure AI Stack. With the Azure AI Stack, you have the flexibility to start as high as you can and go as low as you need. At the top, with Applied AI Services, you can use specific applications, including Bot Service and Form Recognizer. Below that are Azure Cognitive Services, which are domain-specific pre-trained models. Cognitive Services are built on the foundation of Azure Machine Learning. As a user of Cognitive Services, you don't need to know that. But if you do want access to that foundational layer, you can get that by using Azure Machine Learning directly. Azure Machine Learning is a managed end-to-end machine learning platform for building, training, deploying, and operating machine learning models responsibly and securely at scale. Those models can then be accessed by any application that wants to benefit from them. Let's dive deeper into Azure Machine Learning, or the shorter name I will be using, Azure ML. Today, we see around 7,000 customers using Azure ML. And of course, each of those customer accounts has dozens and in some cases hundreds of users. So the number of people benefiting from Azure ML is even larger. In addition to direct customers, ISVs and SIs are excited to build on and extend Azure ML with more than 8,500 partners helping their customers make the most out of Azure AI. While many folks build models and train models, the journey is not over until the model is in production, used actively. In other words, until there are inference requests made against the model. When we look at the aggregate number that Azure ML serves, it exceeds 70 billion inference requests per month. Thank you to all of you who are already using Azure ML in production today, and we look forward to sharing your case studies in the future. Let me share one customer case study, Beiersdorf. Beiersdorf is a leading manufacturer and retailer of some of the most famous skincare, including Nivea. Beiersdorf built an internal data science service with Azure ML as the foundation. This service centralizes all the machine learning projects, creating a single space where data scientists from different departments like finance, marketing, and supply chain can do everything they need to build and deploy applications. Beiersdorf appreciates the fact that Azure ML natively integrates with Azure DevOps, ensuring repeatability by automatically enabling CI/CD and the retraining of machine learning models. With the service, Beiersdorf now applies machine learning to many business functions, such as demand forecasting and product recommendations. Now, for those of you who are not using Azure ML yet, let me give you an overview before we switch to some cool demos. It starts with data. And Azure ML supports multiple data sources for data preparation, including what you see on the left side of the slide. Whether you're working with structured or unstructured data, resulting in classical machine learning or deep learning, Azure ML has you covered for building your models on your data. If we skip the middle phases, it ends with the machine learning models in production. Models that are being used by either your own custom application or by another Microsoft product like you see on the right side of the slide. And those models can be invoked in real time, for example, calling a REST endpoint, or in a more batch processing style, for example, in the context of a stored procedure. One point to take away is that Azure ML is not an island. It is well integrated with all the relevant Microsoft products. At the Build conference, we introduced the Microsoft Intelligent Data Platform. Azure ML is a key service to bridge the two layers you see on the slide and turn data into actionable insights. Let's double-click on the Azure ML box to see inside. The way you typically interact with Azure ML is through the Azure ML Studio web user interface. I call it the Studio UI. In the Studio UI, you have options of building and training your model using automated ML, which is a no-code approach, the designer and the built-in drag-and-drop components, which is a partial code approach, or a full code approach with scripts and notebooks. And when you choose the scripts or notebooks approach, you can do that in your favorite editor if you have one, like VS Code, or you can do it right there in the Azure ML Studio UI. And you can bring whatever library or framework you wish, such as TensorFlow or PyTorch or anything else. As you build a model, Azure ML keeps track of everything so that you know who is doing what and what is getting used and how. Azure ML facilitates a reproducible process all the way to deployment and monitoring, a process that you can automate and audit. And you can run all that in the cloud, on Azure ML's compute instance, on Azure ML's compute clusters, or via Azure Kubernetes Service, and also on premises by bringing your own Arc-enabled Kubernetes clusters. And you can even do hybrid between Azure, on-prem, other clouds, and even at the edge. Regardless of where your compute is running, Azure ML can help you implement a responsible MLOps process for your entire ML lifecycle. Speaking of the ML lifecycle, you have no doubt seen the standard way we talk about the machine learning lifecycle, which looks like something like this linear progression depicted on the slide. Theoretically, and if you squint at this from afar, the truth is close to this linear approach. You get your data prepared, build a model, train it, deploy it, and monitor it. And Azure ML can help you with each and all of those phases. Today, I'd like to share with you a more realistic view of the enterprise ML lifecycle, which is more iterative and represents a more agile approach of going back and forth between different phases as if they were circulating in multiple loops. From our research with both internal and external Azure ML customers, we've established what we're calling the enterprise machine learning lifecycle. This iterative loop structure is still underpinned by responsible AI and MLOps, but focuses on the nonlinear and iterative nature required in the practice of data science at scale. Our research shows this process in 3 distinct loops encompassed by a 4th loop. First, we have the prototyping loop, which is centered around experimentation. In this loop, you have typically a single data scientist working locally, which can mean on their own local machine or on the workstation in the cloud, using an exploratory, interactive approach, for example with notebooks. They work with a subset of the data, getting to understand and shape the data in the context of the business problem. And generally, they're trying to validate or invalidate hypotheses. When they're successful, the result is a minimally viable model, and the lifecycle advances to the next loop for training. In the training loop, it is all about scaling. Scaling to more people being involved, which increases the collaboration needs, scaling to the full larger datasets, and scaling to larger and additional compute targets. This is also where we gather insights about the model itself, computing offline evaluation metrics and responsible AI reports. We also want to ensure that the experiments are reproducible and easily repeatable via automation, breaking the notebook files into modules or components. If the cross-discipline and cross-functional team is not happy and they think they need to go back to square one, they can revert to the first loop. When the team is happy with the results of training and offline validation, the output of the training loop is a candidate model that's ready to be prepared for production. And then we progress to the 3rd loop, operationalizing. It's in this loop that we deploy to production the model for inferencing. It includes packaging the model, online validation of the performance of the model with the data occurring in the wild, and running A/B deployment tests to ensure that we're serving the best model for the job. This is where our investments into machine learning really pay dividends back to the business. Essential to this loop is monitoring. That is how we'll know if the model begins to drift, whether due to data or due to concept. And we may need to move back to the training loop to retrain the model with the new data, or even revert the project back to prototyping if the algorithm itself needs to be revisited. An overall takeaway from our observations is that the enterprise machine learning lifecycle is an inherently messy practice. It begins with creativity at the prototyping loop, and as the lifecycle progresses, it must become increasingly rigid to conform with enterprise requirements. This is where the encompassing management loop enters the picture. It provides a framework for governance, management, cost controls, and security to allow organizations to release deliverables not only more frequently, but also to meet compliance requirements. Now that you have a high-level understanding of what Azure ML has to offer and how we view the end-to-end enterprise machine learning lifecycle in the real world, let's see Azure ML in action. My colleagues, Jessica and Facundo, are acting as if they work for Contoso. They're going to create an NLP model. The model will help them automatically classify the Contoso product comments that get posted on the web. The comments will be classified on a scale from 1, which is bad, to 5, which is good. Let's see how they will get started on the task. Facundo, over to you.
Thank you, Daniel. Hi, everyone. My name is Facundo Santiago, and I'm a product manager in Azure Machine Learning. Let's spend some time together trying to solve this problem using the loops concept we just saw and Azure Machine Learning. Let's jump into my laptop.
As Daniel mentioned, the prototyping loop is all about experimentation and hypothesis validation. I usually feel comfortable starting drafting some code, so let's use Azure ML Studio to start working in a notebook. Fortunately, I already registered the data as a data asset in my workspace, so I can mount it directly to the notebook. Let's select it from the list, give it a name, and click on Create. This is a small sample of the original data, so I can iterate faster. Once mounted, I can use any library I want to explore the data as they were local files in my computer. I just need to grab the path where the files were mounted. In this case, I'm using the pandas library to read it, so I just want to do pd.readcsv, and that's it, easy peasy. This is a great start, but now I'm seeing that the data itself looks like a typical NLP classification problem. Let's work smart here and use automated ML to generate a baseline model to validate our assumptions. Let's start a new automated ML job. Fortunately, my data is already registered as a dataset, so I can select it directly. It has 3 columns, the text, the title of the review, and the rating or label. I configure the experiment name and the column I want to predict. In this case, the label here contains the rating the user gave to the product, so that will be. Finally, I will decide where I want to run my training. AutoML can leverage GPU acceleration, so let's use it. Now it's time to select the task. We want to classify the reviews from 1 to 5. Our problem is a multi-class classification, text in English. Additionally, I can configure which metric I want my model to focus on and how much time I want to spend in finding the best one. This is a great way to keep my experimentation on budget. Finally, it's time to decide how to evaluate the performance of the model. I already indicated the metric, but I want to calculate it on a separate data set so I can ensure that my model is actually learning something. Once I'm done, we just need to click on Finish. AutoML will get the job started. It may take some time, but don't worry, I already have one finished that we can review. Let's see it. We can see that AutoML has found a model with a good performance considering the level of effort we just put on it. 91% of accuracy in this model. I can directly deploy it and test it out, but before moving any further, let's generate the training code that created the winning model. Having the training code is handy since I can use it to further iterate over it, customize something, or even learn about what is being done. I'm using the code generation feature available for automated ML, and it will generate it for me with all the required code to reproduce the same model, including the training routine in this script.py file. Great. I will have a look at this later, but now let's get back to Daniel.
Thank you, Facundo. You saw in the demo one of the many approaches you can use with Azure ML to quickly prototype and get to a working ML model. Regardless of whether you take a code-first approach with notebooks or Python scripts, or whether you start with the Azure ML drag-and-drop designer, or whether you start with automated ML, like in the demo, you will want to scale that training and make it repeatable and automatable. One of the most powerful ways to do that is by using Azure ML pipelines. Let's see that in action. Back to you, Facundo.
Thanks, Daniel. The model automated ML found is a great baseline, but I know some colleagues can be solving similar NLP problems in their department using GPT-2 models. I heard they got great results. Let's see if I can find any reusable component in my organization registry that I can borrow. Registries is a feature in Azure ML that allows different teams to share ML assets across multiple workspaces. The team working with GPT-2 was working in their own workspace, but they promoted the components to a shared registry. Here we can see a fine-tuned Hugging Face model component, and it looks like someone even took the time to write detailed documentation. I can also see here there is a preprocessing component. This is a real gem. Preprocessing is usually code you don't want to write twice. Okay, let's try to reuse these components in a new pipeline. First things first, let's train my training data and my evaluation data. Let's also use the preprocessing text component we found before to help me with long sequences of text. The search box can search for components across all the organization. We will work with sequences of text of no more than 200 words. Instead of truncating them, let's split them, bring in 20 words as context from the previous text. We have to ensure we are applying also the same preprocessing to both training and evaluation data. So Ctrl+C, Ctrl+V will do the trick. Nice. Now, let's grab the rest of the components we need. Again, I'm using the search box to find them. First, a fine-tuned Hugging Face classifier and the baseline model I want to use for it. Hugging Face is a great resource for reusing well-known model architectures and fine-tuning them with your own data. I will ask for the GPT-2 model here from the model list. Finally, let's configure the fine-tuning component. I will configure the columns where the data is, the number of labels, and the evaluation method I want to use for evaluation. Now I connect the model weights, the tokenizer we're going to use, and the data that the model will be used for fine-tuning, the training data, and the evaluation data. This looks very good. Now let's run this in a new experiment and see what are the results. To save yourself some time, I already have a job finished. That's it. Wow, training took almost 2 hours, but it makes sense, right? GPT-2 is a massive language model, and my dataset is not small at all either. Even fine-tuning on a GPU would take time. I'm wondering if there is a way to make this performance better. My colleague Jessica has a lot of experience with high-performance training. Maybe worth asking her. But before that, let's get back to Daniel.
Thank you, Facundo. You saw in the demo components and pipelines in action. They are the building blocks for operationalizing models, and they are foundational to an MLOps platform. You also saw the brand new capability of registries, which facilitates blessing assets, such as components, for reuse across the organization. Next, we'll see what other tricks Azure ML has up its sleeve to help optimize things even further. Jessica, over to you.
Thank you, Daniel. Hi, everyone. My name is Jessica Chaffee, and I'm a product manager in Azure Machine Learning. I'll be looking at Facundo's training job to see if there's any way that we can accelerate the performance. Facundo is training his model by fine-tuning a Hugging Face classifier and using the Transformers library with PyTorch. This is a great candidate for GPU acceleration. My team has been developing a curated environment that is optimized for large, distributed, deep learning workloads and has the best of Microsoft technologies for accelerated training. Let's dive right into it to see if using this environment and our components can get us the performance gains that we're looking for. Facundo is using the fine-tuned Hugging Face classifier component. My team created a similar one that takes advantage of deep speed acceleration by using the new Azure container for PyTorch curated environment. I will search for it, select it, and drag it over to use instead. Now I will make the configuration the same by aligning all of the parameters, and I don't want to forget to set the deep speed flag to true. Now, let's submit the experiment and see how much time it takes. Wow, it now takes half the time. Same compute, same data, and same code. This was a quick win that can save us a good amount of time and budget. Now with good metrics and an overall training time that we can continue to afford, let's register it so we can manage its lifecycle. The model was automatically detected as MLflow, which will be useful later to make quick deployments with it. Let's give it a name and register. Now that the model is registered, I'm creating a simple deployment in my workspace to ensure that it is working and there are no surprises. From the model page, I can select to deploy to either online or batch endpoints. Let's use an online endpoint. I will give it a name and use the default security configuration. See how I'm not prompted for an inference environment nor a scoring script? The model was registered using the MLflow format, so Azure ML will take care of that. Once deployed, I can run it over some sample data to ensure it works. Beautiful. I can get the predictions as expected, all along with the confidence level of the prediction. Now it's time to make my way to production. So far, I've been working on my workspace, but I can't deploy it to production directly. Those workspaces are not managed by my team. Of course, I could just download the model and hand it over, but I really want to keep the lineage, so in case something goes wrong with the model, we can track down how it was built. Let's add it to a registry instead. This way, I can promote the model from my workspace to our organization models repository. Having a centralized repository of models allows for easier management of the model lifecycle across multiple environments. It also helps serve as the source of truth to understand which models have been deployed where. Now, the model is ready to make its way to production. Daniel, back to you.
Thank you, Jessica. You saw in the demo the Azure Container for PyTorch. It is a great example of a partnership we have with Meta. At the Build conference, Meta announced that they selected Microsoft as strategic cloud provider to advance AI research and deepen PyTorch collaboration. PyTorch has transitioned to the Linux Foundation, where it will live under the newly formed PyTorch Foundation to sustain long-term success of the framework. Today, I'm excited to share that Microsoft joined the PyTorch Foundation as one of the board members to continue to grow the PyTorch community by providing technical direction based on our latest AI technologies and research. You also saw in the demo managed endpoints being used for testing purposes, and you'll see them later used for production. It was great to see how Jessica took advantage of the quick deployment experience they provide. We announced general availability of managed endpoints at Build, so check that out if you haven't already. Back to the demo. Now that we have a model that we like and we added it to the organization registry, let's see how we can give it life by deploying it to production. Back to you, Facundo.
Thanks, Daniel. Jessica made an awesome improvement in the performance of the model, and she published it to the organization registry. I can navigate to it by going to Azure ML Studio and then selecting Registries. In the Models tab, I will find it. Here it is. Great. Let's see it. See how Azure ML is tracking lineage by telling me about the job from where the model is coming from. This is key to know how the model was trained and over which data. Okay, let's deploy it. I will click on Deploy and select the workspace I want to target. In this case, the production workspace. My organization has dedicated workspace for production, and the security configuration there is different, so I will select it. The registry has the visibility at the tenant level, so I can target any workspace I have permission for. Let's configure the deployment now. We already have a previous version of the model running, and considering it serves a very important feature in our website, I would rather take it slowly and do a progressive rollout of this new version. Safety first. Manage endpoints allow me to do that by creating a new deployment under the same endpoint, so I don't have to choose one or the other. Finally, let's update how the traffic will be split between the two models. Let's give our new model just 10% for the traffic and see how it behaves. Awesome. The model is running in Azure ML Managed Inference in a matter of clicks, and the endpoint is running both models at the same time. Once I feel more comfortable with it, I can adjust the traffic gradually to the new model until we can decommission the previous one. Before I run out of time, I would like to show you a glimpse of what you can achieve with registries. As you saw, they are also a great way to orchestrate deployments across multiple environments, and I can use it along with Azure DevOps pipelines or GitHub Actions to automate release, all while keeping a single source of truth. Take a look at this continuous deployment workflow I created in GitHub Actions. It has several stages where models are first evaluated and then deployed to multiple environments depending on it. Here, evaluation decided this new model is better than the previous one and is waiting for my authorization to deploy it. This is super powerful. Okay, I already talked too much. Let's get back to Daniel.
Thank you, Facundo. That wraps up the demos for today. Let's review some of the announcements. You saw in the demo Azure ML Registries, which are now in public preview. Using registries will help collaboration across your team and across your projects. Registries will accelerate your MLOps journey. Registries provide a centralized repository for assets such as models, components, and environments that can then be referenced from everywhere, all while keeping governance, lineage, and tracking across all the Azure ML workspaces. Also now in preview, you saw the Azure Container for PyTorch with pre-installed and pre-configured packages that ensure your workloads will go as fast as possible. You also saw the new AutoML support for NLP, which is now generally available along with support for images. On top of that, you saw the new capability of AutoML code generation, which is now also generally available. Now everybody can start with AutoML, and if you want to explore the code to learn or to improve it further, generate the code and continue from there. In addition to what you saw in the demos, there are other improvements that we didn't have time to cover earlier, so I will briefly touch on them now. Azure ML now has a native Apache Spark experience. You can easily spin up a serverless Spark session in Azure ML to do interactive data pre-processing tasks at scale using Jupyter Notebook in Azure ML Studio. When you're ready to promote to production, you can seamlessly transition to a job or pipeline via the Azure ML Studio UI or the SDK or the CLI. Apache Spark in Azure ML is based on the same Spark implementation found in Synapse Analytics, which means it inherits the same benefits, including speed and efficiency, scalability, and more. I'm also excited to announce the imminent general availability of the Responsible AI dashboard, which includes multiple tools to help identify bias and debug the model. These tools are helpful, if not essential, in highly regulated industries and for scenarios with sensitive data. Even if you're not in a regulated industry yet, and even if you're not working with sensitive data, you should check out the tools in the RAI dashboard, which will help you create higher quality models in general. In the demos, you saw a lot of the Azure ML Studio UI. With Azure ML, our goal is that anything you can do with the Studio UI, you can also achieve with the SDK and the CLI. Today, I'm excited to announce the general availability of the Azure ML Python SDK v2. This follows the general availability of the CLI v2 we announced at Build and is complemented by corresponding updates to the Azure ML Studio UI. Together, the v2 of the entire platform brings consistency and ease of use and allows you to easily move from simple to more advanced functionality in an incremental manner. Thank you for joining us in this breakout session at Ignite. You now know that by using Azure ML, you can improve your time to value with integrated tools, you can operationalize at scale with MLOps to deliver responsible solutions, and you can rest assured you're doing that development on a secure, hybrid, and compliant platform. That is why we say that Azure ML empowers teams of ML professionals to quickly create and operate enterprise-grade ML solutions while preserving the familiarity of standard practices. If you have any questions about Azure ML, you can connect with our product team in the Ask the Expert sessions that will be happening both in person and online. In addition to this breakout session, I highly recommend you check out our other sessions on AI topics. Now, I'd like to leave you with an exciting video of one of our customers, Fashable. Fashable is using Azure ML to transform the way they design dresses. I love Fashable's creativity in adopting AI into the fashion industry, and I know you will enjoy watching their story too. On behalf of the entire Azure Machine Learning team, thank you so much for staying with us to the end. Let's roll the video.
How can we keep today's trends out of tomorrow's trash? According to this guy, by using artificial intelligence.
I love AI, so that is very easy to answer. I and my team truly believe that can change completely the status of power on the fashion industry.
Creating a collection takes time, money, and material. Lots of it. And there's no guarantee it'll sell, which we know what that means. But what if you could do it in minutes?
Fashable is using AI that is composed by different neural networks that learns from different data sources. Can be social media, can be e-commerce. So we feed that information on AI, and our AI model will start learning. In one example, what is a dress, different shapes of dress, patterns, sleeves, what is sleeves without sleeves.
In one click, Fashable can create an entire collection, gauge consumer interest, and market online without wasting a single scrap of fabric. So what's their secret?
So we are completely 100% using Azure Machine Learning. Azure is helping us a lot on that because we can start training our AI models without making these kind of investments. And besides that, can help us in our research team to be more faster.
Fashable is using Azure Machine Learning and PyTorch to build AI models that generate clothing designs. With built-in support for popular frameworks and tools, Fashable can choose the resources and libraries they already know and use. Azure Machine Learning has digitally transformed Fashable's business. Now it's your turn. What will you do with it?